Okay, it seems everything working. Please type something in the chat if you can hear me well. And we're starting. As some of you may know, I have finished my talks on Guix Days and EmacsConf, and now I have a little more time and plan to switch from nix-OS to Guix system. And before switching, I decided to make the setup a little better. And today will be kinda talk about what can be done better in modern operating systems, and especially in systems like Guix. And I will try to propose some approach, and later I will try to implement it probably. Okay, let's start from problems of undesired state. If you take a look at this picture, let me check that. Yep, everything works fine. If you take a look at this picture, you will see a graph of many nodes of different color, and imagine that it's some software system, and each node represents an object, and each object has some internal state. That means that to reproduce the state of this software system, you need to create each object which with some state inside it, and it's pretty hard. And it's also hard to take part of the system and to operate on it, because it can depend on other parts of the system. And many people familiar with functional programming know that it's a good idea to try to separate state and to make it as small and maintainable and placed somewhere in one place, and everything else will be something like a pure function of this state. Only few places for state, and everything else somehow operate on this state. And it's good because you will be able to take, for example, this green part of the system and work on it as a separate part of the system. And if you have reduced number of items of your system which contain state, that means that every other parts of the system become separated from these nodes, and you can treat them as a separate thing. And for example, if it's a function operating on some state, it can be used even without the state. You just create a value of the same type and provide to this function, and this function using this function can operate on the result of this function, or can operate on a new value generated by yourself. That means it makes the design of software system much more robust, testable, and so on. Yep, it's a basic idea, but very important. It's much easier to reason about such systems. It's much simpler to understand where and when something changed, and it's much harder to make any mistakes if you architect your system in such a way. But in modern operating systems, it's a very usual thing that you have a state which spread across the whole file system, and you can change separate files, separate configurations. You can forget about them, and you also can change some runtime state, for example, add IP tables rules, and so on. And after reboot, you will get problems. After update, you will get problems. Or when you will try to replicate the same setup on another machine, you just forgot to replicate one of those steps, and you will get non-working system. or you did it later when some packages updated, and even if you did the same steps, but in another point of time, it will lead to a different result, and you will have some problems. And the question, is it possible to make something similar to functional programming approach, to make your operating system stateless? The general answer to this question is no. It's not possible to make operating system stateless, because that means this operating system won't work. Anyway, you have some internal state. For example, number of packages went through firewall. Your IP address obtained by DHCP, and many other things. But talking about those things, we can say that we don't care about them. First of all, we can shut down our operating system and bring it up, and nothing bad will happen if it doesn't saved any of this information somewhere. We will obtain it somehow. And also, part of this information will be brought by external sources, which we can't change somehow anyway. And there are some parts of the system that we are in charge of and that we can change. For example, some state of some programs. Network manager stores connections to Wi-Fi networks. Databases store cache and data or somewhere on hard drive. Some programs store configurations. But both of those things can be improved, and we can split the state to one place and remove some of this state at all. For example, solving the first problem of storing some information of some system applications, we can place them inside configuration, and we can say that we revision this configuration with some version control system, for example Git, and our operating system will be the result of applying some function to this configuration and list of packages. List of packages is also revisioned. That means that we always know what version of packages will go to resulting system. And having such approach, we getting system that is immutable and doesn't have any problems that someday we changed configuration, forgot to write it in documentation or in some deployment script or something else. We have always latest version of result of our function, which produce operating system from our configuration. A small problem that you can't place inside such configuration any secrets, because they will be leaked and will be available on your build server or something like that. That is why this line looks cool, and it will be very cool if it worked this way, but in reality you have somehow provide a security key to your host, and having your immutable operating system and this security key, it's possible to see what encrypted data placed in your configuration, and it's almost a real picture. You can do the following step using modern package managers like Nix and Guix, and yep, it's something that already possible, but it's not the complete solution, because we not decided what to do with database cache and other data of other applications. But we already almost solved the problem of storing configuration of some system services and packages. Okay, and our ideal workflow will look the following. We have a running system and it works pretty fine. We can turn our system off, take our storage, throw it out, insert new one, completely blank. After that we boot from USB stick or from network, and cloning our configuration, revisioned and controlled by Git, for example. And after that we apply a command for partitioning our new device, and after that we install our system from the configuration, and this configuration will also contain the exact revision of packages and some credentials. Actually, I didn't place a step about security key here, but you can imagine how it will look. It's almost complete workflow, and it almost like it looks when you're installing nix-OS or Guix system. But it obviously won't bring anything that was previously available on your system, because when you work on some system, you produce some state anyway. You produce tables in database, you produce files in your project, and so on. And we need to work around this problem somehow. But first, let's talk about previous problem that we almost solved, but we're still not sure that it's solved completely. This idea is highly inspired by Erase Your Darlings article. I place a link right here. Idea is following, that to be sure that everything in our configuration that produce our new operating system, we need to make on each boot, we need to erase our root file system and let our bootloader to run a script which will symlink all necessary files from our immutable operating system to this root. And if everything works fine, we are good, we didn't break anything. And to be a little more precise, after boot, we can snapshot the current state of our operating system. And after some time, we can check if something changed on this file system. And if something changed, it's obviously some state. If it's some state like cache or something like that, that is not very important for us, we can just let it here, and after reboot it will be erased. Or if it's something important like credentials of your network manager or some data, we have to deal with it, and we have to move it to configuration. For example, if we see that network manager stores some values on our file system, we move it to configuration file and makes our system already containing this data inside it, and it moved from state to configuration, which is pretty good, which increase reproducibility and remove undesired state. Cool. Now I think that we solved the first problem. Now let's go to the second problem, and the second problem was some applications that create a lot of data, and what we can do about it. We can change our problem to the following. We have Immutable OS, which works already very good. We found everything that we need to place in configuration. and moved it to configuration, and we don't have any state inside our operating system. And every service or program we move to user space. It may be everything like database, your project, software project, or something like browser or email client or anything else. And now we need to solve a problem of managing state for user. Let's take a look how it can be implemented in some pseudocode. I created a table when I reasoning about how to do it better, and placed some important folders here. That means it's something in my home folder, and there's something on a separate partition that will be linked to my home folder, and also there's some initial values for those things, and also some information about if it's synchronizable or not. And I came up with following idea, that we can create a file which defines all necessary places that we have to be aware of, which contains the state. For example, it obviously that I want to keep my org files under version control, and I want to be sure that when I erasing my system, those files will be restored easily from initial values. Okay, let's see how it look. We're doing partitioning of our storage. We deploy security key. If you have hardware security key, it's an optional step. And after that, you install your operating system. And after that, you instantiate your state, like cloning all defined repositories, all defined remote sources to some place on your hard drive. And after reboot, you will get your immutable operating system, which contains everything that's necessary for working. And you contain all the state you can work with, and every program and service in user space will be fine, because it has all necessary data that it can desire. And how to achieve it, and how to be sure that we didn't forget about anything. We do the similar thing, but now we have additional steps. Previously, we had our operating system erased on every boot, and a script linking everything to the root partition. And after that, we taking a snapshot and checking if something new appeared here after snapshot. And if something appeared, it should be removed, or it should be moved to configuration. It's a little different for user state. If we find that something appeared and not under our control, and we are not aware of it, we have two options: remove it, or find programs that bring the state and remove this program. Or we can define our explicit state in some file, and it will look something like that. We issue a comment, see everything that appeared after a snapshot. For non-revisioned files, or everything that appeared but not committed in repositories. And after that, we can add it to our state file, which defines all state in our system. Or we can remove it and related programs that created the state. And after that, we issue sync comment, which make everything synchronized with remote repositories or remote storages. And after that, we issue status and see that everything synchronized and good. And we are happy that we don't have any uncontrolled or undesired state in our system. And now if we remove the whole system and reinstall it from ground up, we will get almost the same system with almost the same data that we have before. I say it almost because there are few different types of state. I came up with them just a few hours ago, and it's not a comprehensive list, but something to start with. First of all, credentials and secrets. There are two parts: your secret key that you have to deploy separately, or you have to have a hardware secret key, and other credentials that will become a part of your immutable operating system configuration. And actually, knowing that, we already don't care about it. Cache. In some cases, cache is important. For example, for high load web services, and it's necessary to take care of it. But in basic case, in most cases, you don't need to care about cache, and you can delete it, or you can make it untrackable for our tool, and it will be removed if something goes wrong, but we don't care about it. Remote file systems, you can mount Samba or SSHFS and work with this data, but we don't care about it. Someone from remote machine have to care about it, about backing it up and so on. We just use it as it is, and on the case of wipe of our operating system, we will be able to remount those remote file system in almost the same manner and won't lose anything. It's a good idea how to check that your system is reproducible. Just wipe your hard drive and reinstall it and see what goes wrong, and you will find a weak points of your setup. Revisionable data. It's very popular right now to revision almost everything. Your nodes, your source code, your finances, and many other things, even passwords. And it's a good thing because it's some kind of state, but when you committed this state and synchronized it with remote repository, you can easily reproduce the same state with just one command like git clone or git pull. And it's a cool state, and I quite like such state, and we already know how to deal with it. Archive state, it's kind of files that you want to persist somewhere, but you don't care if they exist on your newly created machine or not. For example, some photos, you have them on your laptop and you want to have a schedule for archiving them, like every week you move all your photos to remote server in your garage or somewhere else. And when you wiping your system and installing new one, you don't need to care about getting those photos back to your laptop. Backup is almost the same, but with very important difference that you need to bring this data back. For example, you have database, you did some work, it stored some data, it's this data backed up by RDE state sync tool. And after installation, RD tool will, when you call init function on state, it will bring back all backed up data, latest version of backed up data back to your machine. And media. This data can be treated differently. For example, large videos like films and something similar can be treated as archive. Pics, articles, books can be treated as backup data, and music can be treated as both backup and archive data. I mean, one of those. For example, it's up to you and to your setup. And last part is encrypted data. I think it's kind of subset of something mentioned previously. If it's a big file, it should be archived or backupped. If it's a small file like passwords of your password manager, it should be revisioned by some version control tool. And yep, it's almost all types that I came up. Maybe I will find something else that not covered here, but for beginning it seems pretty good. And going to conclusion, it seems it's very possible to make a really reproducible setup which cares not only about your operating system but about the state. And it's possible to split your computing environment into two parts: easily reproducible immutable operating system and your user space state, which both can be reproduced somehow, maybe with different tools, but relatively easily. It's just an idea of how it can be implemented, and I probably will try to do something like that during next 2 weeks, and probably on the next stream we'll report some results. I will place this file. I will place a link to this file in the description of the stream. I hope you enjoyed and glad you joined the stream. See you later.